Hey everyone, today we're going to be looking at section 14.1 and its counting outcomes. And one important thing is learning about how to make a tree diagram. A tree diagram is a diagram that's used to show the total number of possible outcomes, and they're really beneficial. Sometimes if we're trying to figure out probability, tree diagrams are helpful. They can be huge, and those are really tough. You need a lot of paper, a lot of organization, or they can be a little bit smaller. I always like using abbreviations if possible, so I don't have to write as much out. Tree diagrams, sometimes though, you can draw them from top down like this, or you can go left to right like this. So depending on your preference, you can make tree diagrams two different ways. So let's try number one. At a football game, a student concession stand sells sandwiches on either wheat or rye bread. So notice I put bold W and R. We're going to use those in our tree diagram to make it a little bit less to right. The sandwiches can come with salami, that'll be S, turkey, T, or ham, H. And you can either get chips, a brownie, or fruit. So we're going to make a tree diagram to determine the total number of combinations. And it's important here. You will know other ways of figuring out how many combinations, but if they ask you to make a tree diagram, you do need to make that tree diagram. So I'm going to do my best here, and I might stop the video and fill it out a little bit easier for me that way than writing on here. But I'm going to start with W or R. That is the bread I can get, W or R. And try to keep it spaced out because we're going to have lots of branches. Now, I can have wheat bread with salami. I can have wheat bread with turkey. Or I can have wheat bread with ham. I could pick rye with salami. I can pick rye with turkey. Or I could pick rye with ham. So far, I have 1, 2, 3, 4, 5, 6 different options just for types of bread and the type of meat. Now for my sides, I can do a chip, brownie, or fruit. So I'm just going to change the color in case it gets a little challenging here. So chips, brownie, fruit. Chips, brownie, fruit. So go ahead and continue on for every ending branch to the chips, brownie, and fruit. All right, so now how many do we have? 3, 3, 3. So how many groups of 3 do we have? Well, we have 1, 2, 3, 4, 5, 6 groups of 3. So we have 18 different combinations. So if I ask, hey, what's the probability of having wheat bread, ham, and fruit? Well, wheat bread, ham, and fruit would be here, right? So there's one way of doing that out of 18. So a lot of times we use probability for that. What's the chance you pick rye bread? Well, half of them have rye, the other half have wheat. So rye bread, chances of you picking rye would be 1/2. So that leads us into what's called the fundamental counting principle. If you do not have to make a tree diagram for a problem and it wants to know, hey, how many different ways could you do this? What you do is you pick all the choices you have. So I had 2 choices for my bread. I had 3 choices for my meats, and I have 3 choices for my sides. So you multiply those 3 values, and that will tell you how many different possibilities you have if you don't need to draw that tree diagram. So let's try that with problem 2. The Too Cheap Computer Company sells custom-made personal computers. You can choose from 11 different hard drives, 6 different keyboards, 4 different mice, and 4 different monitors. So how many custom computers can you order? Again, we don't need a tree diagram. So we're going to take our options for hard drives, multiply it by our options for keyboards, options for my mice, and options for my monitor. And you might want to grab a calculator there. We get 56 different possibilities. So that's our fundamental counting principle. So now we're getting to use some exclamation points in math. Those mean actually factorial. So if you see n factorial, that's the way you read it, n factorial. The letter n is representing any number greater than 0, and that means the product of every number that starts with n and counts backwards to 1. And again, product is multiplication. If you have a calculator like we in the classroom, you can explore that. You can take your calculator, second row down, you'll see the button that says PRB. That means probability. And then you can see like NPR, NCR, and then the exclamation point. So if you want to try it with your calculator later, you can do something like this. You're going to hit the number 3, and then you hit the PRB button. Arrow over to the exclamation point, and then hit equals or enter. What that does is it does 3 factorial. And what does 3 factorial mean? Well, that means 3 times 2 times 1, or 6. Let's try problem 2. We're going to do 5 factorial. We want to show what it means. So what does 5 factorial mean? It means 5 times 4 times 3 times 2 times 1. So if we don't have a calculator, we can do this one out. 20 times 6 is 120. So 5 factorial is 120. What does 9 factorial mean? 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you have a calculator, enter that in. If not, we'll do the little drum roll, please. Here it is. 362,880. That is not something we expect you to multiply without a calculator. So you can use a calculator, you can use that factorial button. It's the exclamation point. So let's look at why we have this factorial. So problem 3, there's 8 students in the algebra club at Central High School. Hey, that's my school. We want to stand in line for our yearbook picture. How many different ways could the 8 students stand for their picture? So let's think about it. I have 8 lines I drew here. How many options do I have? I have 8 kids. How many people do I have to pick from that would stand here on the left? Well, if there's 8 kids, I have 8 people to choose from to stand here. Now, who's going to stand next to that person? Well, I have one person here already. So how many are left? There are 7 kids left. So 7 kids are left to take that second spot. So 2 kids are in the position. How many kids are left to choose from to stand here? I have 6 kids left. How many more kids to choose from? 5. Do you see what's going on? I have 4 people to choose from, 3 people to choose from, only 2 people left, and if I have 7 of them lined up, there's only 1 person left over for that last spot on the right. So we're going to multiply those together. Again, if we have a calculator, we can just do 8 factorial. And that's what it means. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 8 factorial happens to be 40,320. I think the picture sometimes really helps you understand what you need to do. Let's try another one together. Jill and Miranda are going to a national park for their vacation. Near the campground, there are 8 different hiking trails. So for part A, how many different ways can they hike all the trails if they hike each trail only once? So how many options for the first trail they decide to go on? Well, there's 8 trails. How many options for the second? 7 trails. Then 6, 5, 4, 3, 2, 1. So this one, thankfully, is just like the other one. It's 8 factorial, which is 40,320. Now, they don't have the time to do 8 different hiking trails. So they can only hike 5 trails. How many ways can they do this? So how many do they have to choose from again? There's 8 different trails that they can hike. So they have 8 to choose from for their first hike. And then they have 7. And then they have 6. and then they have 5, and then they have 4 to choose from. So a lot of times people do 5, 4, 3, 2, 1, but they still have more options. So it's 8 to choose, 7, 6, 5, 4. So we can't use a factorial this time. We can just go ahead and multiply that with a calculator, and I'll do that magical multiplication for you. It is 6,720 different ways to hike 5 of the 8 trails. So this is factorials, and we had tree diagrams, the fundamental counting principle earlier. Hopefully you understand this pretty well. I always say draw it out, make those lines, understand the problem. I think it's actually better than trying to memorize the formulas, because you don't want to go through life saying, what was that formula again? But if you have paper or something, you can graph it, draw it out. You'll remember how to do it a lot better. So we're going to move on to section 14.2 in the next video. Hopefully everyone's good with these 3 topics now.